Welcome to the first in our new Team Black Sheep PowerCube series. In this little series we're going to be going through the basics of this thing here. This is the PowerCube, and this replaces the majority of the electronics that you'd have on a 250 class racer quad. At the bottom we have a power distribution board, then we have 4 electronic speed controllers that connect up to your motors, and at the top we have a flight controller. And each of these pieces is connected to the one below it by a little riser, so there's no additional cables needed. By putting the cube together, you're actually making all the connections you need to have both the signals go through those little risers, but also to distribute the power around as well. These brass nuts in each of the corners are actually taking the 12 volts or whatever power supply from the battery and distributing that up and down the cube. So all of the wires that you would need are actually taken care of by some clever design actually inside this stack. We do need to say a very big thank you to Trappy and the team at Team Black Sheep for sending us this piece of technology to try. So in this video what we're going to do is go through each of these levels and explain a little bit about it. So for those of you that are interested in what the PowerCube is, hopefully by the end of this video you'll have a much better idea, and in the following videos then we'll actually install and configure it onto a frame and take it out and fly it. And then following that we'll also do some things with the core, with the on-screen display bits and pieces too. Before we get into the details of the individual pieces, it's worthwhile us talking about the actual cube itself. So the cube is about 36 by 36 millimeters and it's about 30 millimeters high. So it will fit in between the top and bottom plates of things like a ZMR 250 frame or some of the other very common 250 racer class frames. It's about 70 grams in weight. Some of that weight is coming from those nuts in each of the corners that are moving the battery voltage around. You can buy a kit that will reduce that weight by 8 grams, and that's replacing those brass nuts in each of the corners with some lighter nuts that actually have some special coatings on that will still conduct the electricity very well. It is really designed for a racing quad, this version. So the Colibri flight controller that's on the top and the speed controllers and everything else is really designed around FPV 250 class racing quads. So although you can do things like add GPSs and other elements to the flight controller at the top, I would say that this is something you should be considering if you're into that style of quad and that style of flying. So let's go into the first part of the stack and talk a little bit more about what the flight controller is and what all these connections are that are on the top. This is actually a Team Black Sheep Colibri Rate flight controller. Now this is an STM32F3 processor, so we've looked at some other boards that run Clean Flight that have a similar processor to this. This is kind of the big beefy version of the processor that's very capable. It comes pre-supplied with Clean Flight version 1.11. The Clean Flight that comes with it though isn't the default one that you'd install by the Clean Flight software. Team Black Sheep do actually provide their own version of the firmware that you can load onto it, and that's because they've done some special things here to make it work with their on-screen display systems. But we'll talk about that in the next video when we're actually putting everything together. But be aware of that. You can flash it with the standard Clean Flight, but it does mean that you just lose a couple of bits of functionality. Nothing that would stop you flying, but for some of the additional Team Black Sheep peripherals. It includes a MPU 6500 6-axis gyro and accelerometer, which is pretty standard for every board these days, so it can feel side-to-side movement and rotation in all 3 axes. It provides support for PWM and one-shot ESCs, and then it has a load of connectors around the edges. Now we're not going to talk about these on this slide, we'll actually jump into this and do a much closer look in a moment. There is a bootloader switch, so on some other boards that you use with Clean Flight you may have seen that you have to short 2 pads, or there's a couple of pins that you have to put a jumper on. With this it's a little button, so if you want to go into bootloader mode or DFU mode you power it on while pressing this little button, which is a nice feature. It makes it easier to use. And again, all of the power and all of the internal connections out to the speed controllers, down to the power distribution board and everything else is all handled already by all of these individual little risers that are around the outside of the stack. So let's have a little closer look at what all these connections are. So we are looking at the board here in the right orientation. So the front of the board that should be facing the front of your craft is at the top. And on the top of the board, on the left hand side, we have an infrared LED port. Now that is there to provide infrared LED support for things like racing. So the idea with that is that when you're racing your quad, you have an infrared LED that's pulsing, and it allows the timing systems that are starting to be used in 250 racing to identify your craft and also provide the timings for it too. So that is in there ready to go, so you can plug that in at a later date. UART1 is then in the middle. That's just standard I/O port that's in all of the CleanFlight boards, including things like the CC3Ds and others, and that allows you to plug in peripherals. And then on the right of that, we have our buzzer port. And again, buzzers are very handy to use, just for no other reason than they act as fantastic lost model finders when the model flips out of a race and lands in some long grass. Then the USB is on the right hand side of the board, which is a fantastic design element. It means that even when it's mounted inside a 250 racing quad, we can still get at it and plug it in easily to change settings. Then at the back, continuing round on the right hand side, we have our radio receiver port. So as you can see here, we're really looking at S-Bus or PPM. Then in the middle, we have a separate port to plug in a GPS, magnetometer or altimeter. And this is why this is a Colibri race. It doesn't have all of those extra sensors on board. All of those would be auxiliary sensors that you'd add via that port. Then we have support for an LED strip on the left hand side, and for those of you that have seen the other videos, that's the things like the WS2812 individually addressable coloured LEDs. Great feature in CleanFlight that allows you to have those changing colour, doing things in response to control inputs, and that's where you'd plug those guys in. And then on the left hand side, the last couple of things, we have the servo connection. So if you wanted to wire up a servo lead for something like a tricopter, all of the pins are presented there at the side that you can solder onto. And then finally, we have that little thing in the corner is actually the header for the cube connections. And that's the one that connects all of the signal wires right the way from this board all the way through the stack. So now we've looked at the flight controller and we've talked a little bit about that. Let's look at the stuff that's underneath the flight controller, which are the bulletproof 20 amp ESCs. Now there are 4 of these. 2 of them come out at the front and 2 of them come out at the back. And what I mean by that is you can see here that they actually rotated by 180 degrees, and that means that the power connections in the corners are always in the right place. You never want to try and mount these any other way. And it means that with the 2 front motors, we have 2 lots of ESC wires come out the front, and for the rear 2 motors, we have another 2 sets of ESC wires. Now these things are 20 amp capable. These wires are terminated in 2mm bullets. You could obviously clip these off and directly solder your motor onto it. Although I'm very tempted when we do our build to invest in a couple of 2mm bullets, just because it's a lot easier then when you're doing things like checking the rotation of the motor to swap things about. They do come with BL Heli 14.2 pre-installed. You can get Simon K variants as well. We'll fly it with the stock stuff of BL Heli when we build it. It's also one-shot capable. That's just a way that you can provide a faster, cleaner response to the speed controller as well. Then just talking a little bit about the capabilities of the ESCs. Although these are 20 amp ESCs, the 20 amp is for the low rating. So if you're only getting minimal airflow of about 5 miles per hour, so if this cube is out in the air or in the middle of a frame where there's airflow around it and you get decent airflow, then you can actually run these a little bit hotter at 30 amps. And the cube is designed so that you have all of the heat dissipation of these big chunks of metal in each of the corners, but also enough separation so that you can run it an extra 10 amps if you need to. And there's a 45 amp burst capability if you've got it in that good airflow. So I would recommend with this, it's probably not one you're going to want to squirrel away in the middle of something like a ZMR 250 frame and put all the sides on. This is one that if you need it, you can put right in the middle of a frame and put some really hefty motors on too. They are 2S to 6S capable. The majority of racing quads that you tend to come across will usually run on high-end 3S or 4S batteries, but if you really want to push it and go 6S, then it will support that. And again, the way these things work is they are connected to the flight controller at the top via each of these risers that go down each side by side. So you can see here that the top ESC is ESC1, and that's connected on this side via the riser to the flight controller. Then if we flip it round, the next one down is ESC2, that's connected to the bottom of ESC1 by a riser, and then the next one underneath that is ESC3, and so on. Nice thing is, and the smart bit of design here, you don't have to worry or set each of the ESCs so it knows which ESC number it actually is. By plugging these in and daisy chaining them in this way from the flight controller down, it actually automatically indexes the speed controller. So if you had a speed controller that failed and you wanted to replace one, you just undo the nuts, take the flight controller and the working ESC off until you got to the damaged one, then you take the damaged ESC out and replace it, and then rebuild your stack. You don't have to reset any dip switches or anything like that. It will automatically understand which position it is in the stack and automatically configure itself to operate for that motor. Last thing then to talk about as part of the stack is the bottom two pieces. This is actually the power distribution board and also some nice smart DC to DC conversion bits too. So the power distribution board itself can handle 100 amps max, 150 amp burst. So the way this works is that the two screws that you can see at the bottom are actually going into the ground or negative lines. So these two pieces here that the screws are underneath are both of the negative risers. And this bit of plastic at the bottom with the sticky pad is actually protecting the bottom of the cube from any frame that you might put it on that's conductive. So as you probably already know, carbon fibre conducts electricity, so we don't want to be screwing in something that's 12 volts and something that's ground directly into carbon fibre, because it will conduct electricity and you will get some interesting lighting effects. The way this works is that it's designed to be mounted onto the frame using the sticky pad and also these two screws that screw into the bottom of the negative pin risers in each of these two corners on the PowerCube, and that then also provides a solid ground connection to the rest of the frame too, which is a nice touch. There is also a clean 5 volt and 12 volt out for the FPV system. So these two connectors at the front, and we'll look at these in later videos, actually allow us to both power a 12 volt camera and also a 5 volt video transmitter too. So this is a nice idea, and it means that again you don't have to have any additional electronics or battery eliminator circuits. This provides that power out at the side. And if you're using it and putting your video signals from the camera into the video in and the video out comes out of the other port, you can also plug in the TBS PowerCube Pro into this separate connector at the side too, and that will then provide an on-screen display for your quad. So now we've looked at the overview, hopefully for those of you that are thinking of buying this, you have a rough idea what's actually in the stack. In the next video then, what we'll do is we'll connect it up to CleanFlight, we'll have a look at the configuration, and then we'll start to get ourselves a frame and put 4 motors on it. And once we've got a frame with 4 motors on, we are ready to start wiring this up, attaching a battery and a receiver, and getting ready to fly. So we'll cover that in the next video. Thank you for taking the time to watch that video. There are lots of other videos on the channel and they're carefully ordered into playlists, so you may find that there are other videos on this same subject that you can go and watch. So I would recommend going into the playlist area of Painless 360 YouTube channel and looking around and seeing what there is. You never know what you might find. Thanks for watching. Please like, subscribe, and happy flying.